Guys, in this video, we will discuss about how to find the solution of a second order differential equation and what are the types of the solution. So, let's start the discussion. See here that if I consider the differential equation of a second order differential equation, that is d2y dx2 plus d2y dx2 plus p dy dx plus qy is equal to 0. See here the equation d2y dx2 plus p dy dx plus qy is equal to 0. This is a second order differential equation. Since the highest order derivative is here 2, the degree of this equation is 1, and see the coefficient of dy dx and y. Here we consider p and q, and this p and q are constants. So we can say that this is a differential equation of second order. This is a second order differential equation. Second order differential equation, and the degree 1, that means a linear second order differential equation. And since p and q are constants, you can say with constant coefficient. With constant coefficients. So now so if we take some examples, so then what are this time the differential equation examples on the linear second order differential equation with constant coefficients, like d2y dx2 plus 3 dy dx plus 2y is equal to 0. We can say that d2y dx2 plus 4y is equal to 0. We can say d2y dx2 plus 4 dy dx plus 4y is equal to 0. See here that if you take all these three examples and many more, that the degree of each and every equation is 1, order of these three equations is 2, and the coefficient of y and dy dx for all these three cases are constant, that like the different real numbers. So this is the examples and the concept of second order differential equation, basically linear second order differential equation with constant coefficient. So now here that the question is that how to find the solution. So we can find the solution here, this differential equation. Here we will take a trial solution. The trial solution means here we will take y is equal to a e to the power mx as trial solution. Y is equal to a e to the power mx be the trial solution. So trial solution. So from here we will find that dy dx is equal to m a e to the power mx, and d2y dx2 is equal to m square a e to the power mx. And now if we put all these value in this equation, so what we get? We will get m square a e to the power mx plus p a e to the power mx pm e to the power mx plus q a e to the power mx is equal to 0. So now if we write it here, we will get m square plus pm plus q is equal to 0. And this equation is said to be auxiliary equation. This equation is said to be auxiliary equation. And since this is a quadratic equation, so here with the nature of the root we can find the solution of this equation. So now let us discuss that how to find the solution with the help of this auxiliary equation. We can get the solution of this second order differential equation. So now here indicate that the auxiliary equation is m square plus pm plus q is equal to 0. This is a quadratic equation. And we know that this equation contains maximum two roots, and the nature of the roots of this equation, there are four types, like roots are real and distinct. Number two, roots are real and equal. Number three, roots are complex conjugate. And number four, roots are purely imaginary. So now here we have to find the roots of this quadratic equation, and we will find the we will next we will check the nature of the equation, and according to this we will write the solution is of the. So here, if the roots are real and distinct of this equation m square plus pm plus q, so then the solution of the differential equation d2y dx2 plus p dy dx plus qy is equal to 0 is of the form y is equal to a e to the power m1x plus b e to the power m2x. That means here the roots are real and distinct. That means if we solve the equation m square plus pm plus q, we will get two roots, namely m1 and m2. And the solution is of the form y is equal to a e to the power mx, y is equal to a e to the power mx plus b e to the power m2x. And in the next, that means here if we take one example here, like that d2y dx2, here we take one example that d2y dx2 minus 3 dy dx plus 2y is equal to 0. So then its solution is on the form that here we will take y is equal to a to the power mx is the trial solution. Then we will find dy dx and d2y dx2, and you know we will get m e to the power mx and d2y dx2 m square a e to the power mx. And if we put here the equation, we will get the auxiliary equation is on the form m square minus 3m plus 2 is equal to 0. And now if we solve it by using the middle term factor, m square minus 2m minus m plus 2 is equal to 0, or m minus 2 into m minus 1 equal to 0. So we get m is equal to 1 and 2. Roots are real and distinct. So you can write the solution is of the form y is equal to a e to the power x plus b e to the power 2x. Also, you can write the solution is of the form y is equal to a to the power x plus b into the power x. All these two alternatives will be accepted. Okay. And the next, that if the roots are real and equal, then what is the solution type? That if the roots are real and equal, that means if we solve the equation m square plus pm plus q is equal to 0, that means the roots are repeated, and in that case the solution is on the form y is equal to a plus bx into e to the power mx. That means here we will check that y is equal to a plus bx, e to the power mx. That means here, if we consider the equation like d2y dx2 minus 6 dy dx plus 9y is equal to 0. So here, this part will be same. And now if we put here all those, the auxiliary equation will be m square minus 6m plus 9 is equal to 0. And if we want to solve, we will get m minus 3 whole square is equal to 0. So we get the roots m is equal to 3 and 3. And here the value is in 3. So the solution is on the form y is equal to a plus bx into e to the power 3x. Where all these cases a and b are constants. So now here we will, in the next page we will discuss about the number 3 and 4. The roots are when the roots are complex conjugate and purely imaginary. So here the roots are complex conjugate and purely imaginary. That means here the if we consider that m square plus pm plus q is equal to 0. So here if we find the discriminant, or if we want to find the solution by using Sridharacharya, m is equal to minus p plus minus root over p square minus 4q by 2. And here if p square minus 4q less than 0, the pure roots are complex conjugate, and if p is equal to 0 and q is greater than 0, then the roots are purely imaginary. So purely imaginary. And here also you can touch one thing, that if in the previous slide here I show that roots are real and distinct and roots are real and equal. That means here if we find that m square plus pm plus q is equal to 0 and the roots minus p plus minus root over p square minus 4q by 2. For the real and distinct, p square minus 4q is greater than 0. And for the real and equal, p square minus 4q is equal to 0. See here that here if you find the p square minus 4q for this equation, d20 is to minus 6 j, that is p is equal to minus 6, q is equal to 9. So if you find p square minus 4q, it will be 6 square minus 4 into 9, that is 0. And for this one, that is p square minus 4q, that is 9 minus 4 into 2, that is 1 greater than 0. So the roots will be real and distinct, then p square minus 4q is greater than 0. The solution is of this form, and real and equal, then the solution is of this form, y is equal to a plus bx e to the power mx. And now in the next slide we will get that if the roots are purely the when the roots are complex conjugate, the p square minus 4q less than 0. So here we will take two examples, that is d2y dx2 plus dy dx plus y is equal to 0. So here p is equal to 1, q is equal to 1. So here p square minus 4q will be, p square minus 4q will be 1 minus 4, that is minus 3. So the m is of the form minus 1 plus minus minus 3 by 2, and minus 1 means we know I square, so it will be right minus 1 plus minus root 3i by 2. That means here we can write minus a plus minus I into root 3 by 2. That means roots are complex conjugate, and this is the form alpha plus I mixture and alpha minus I mixture. And here alpha is equal to minus a, beta is equal to root 3 by 2. And if the roots are complex conjugate, the solution is of the form y is equal to e to the power alpha x c1 cos beta x plus c2 sine beta x. But c1 and c2 are arbitrary constant. So here the value is alpha is equal to minus half, beta is equal to root 3 by 2. So it will be e to the power minus half x c1 cos root 3 by 2x plus c2 sine root 3 by 2x. This is the solution. And the next part, that is p is equal to 0 and q greater than 0. So here, if we take the solution, or if we take the equation, this equation, and if we make dy dx is equal to 0. For this case, that is, if we take the equation d2y dx2 plus y is equal to 0. See here, p is equal to 0, q is equal to 1, greater than 0. So, p square minus 4q is minus 1, 0 minus p square minus 4q, so 4 into 1, this is minus d2y dx2 plus y is equal to 0. So p square, here p is 0 and q is 1, so it is minus 4. And so now we have to find the solution, that is p square minus 4q, or we can say here that the roots are purely imaginary. Here we don't need to find this one. Okay, this is minus 4, so it is minus 2. You see here the auxiliary equation is of the form m square plus 1 is equal to 0. So from here we can find m is equal to plus minus I. So here the roots are is of form plus minus I beta. If this is plus minus I beta, the solution is of the form y is equal to c1 cos beta x plus c2 sine beta x. And here the value of beta is plus minus I, that is 1. Plus minus I beta here, the value of beta is 1. So it will be c1 cos x plus c2 sin x. So we get the nature of the solution, that is depend on the nature of the roots of the auxiliary equation. So here if we find, in summary you can write d2y dx2 plus p dy dx plus qy is equal to 0. The auxiliary equation is m square plus pm plus q is equal to 0. So then here the roots are minus p plus minus root over p square minus 4q by 2. The roots are real and distinct. In short, roots are real and distinct. That means m1, m2. Solution is y is equal to a to the power m1x plus b e to the power m2x. Roots are real and equal. M and m. Y is equal to a plus bx e to the power mx. Roots are, that means here for this one, p square minus 4q greater than 0. Here p square minus 4q equal to 0. Here roots are complex conjugate, that is p square minus 4q less than 0. That means the solution is on the form. That means the roots are from the alpha plus minus I beta. Y is equal to e to the power alpha x. The solution roots are purely imaginary, means p is equal to 0, q is greater than 0, and the solution is and the roots is of the form plus minus I beta. That means the auxiliary equation m square plus beta square equal to 0. M is equal to plus minus I beta. Solution is of the form y is equal to c1 cos beta x plus c2 sin beta.